Next to me on stage is already Frank Lyaruu. He's a cloud architect and developer with 20 years experience in Java. He's a stream processing and reactive enthusiast, and he's going to talk about sharing responsibly, streaming analytics from sensitive data. So we'll talk about sensitive data. I'm not giving away anything much. Let's listen to Frank's speech. So a round of applause for our first speaker. So Frank, can feel welcome here. So thank you, Frank.
Good morning. Good morning. So I can't really see you well. Hello, people online. I can't see you either. I want to talk about streaming analytics, and I'm going to break down the title more later. But first, I would like to talk about data in general. I mean, in a way, we always talk about data because that's what we do. But if we talk about like data analyst and data analytics, it is often about just getting more and more data because it makes things easier. If you ask analysts like, what data do you need or what do you want? And they just typically give you an answer like something like, just give me everything, as much as possible. And that's sometimes problematic, and we'll get into that. But before that, I'm Frank Lyaruu, as was announced. I am a cloud architect at Quinn, medical scale-up. We are in Amsterdam. Obviously, like everybody else, we're hiring, especially Kotlin or cloud engineers. So if you want to move to Amsterdam, we're even relocating. Let me know, because I'll make it worth your while. But before that, let's tell a story. I think most of you are developers, and suppose we want to make an application. Doesn't really matter what it does, and if we make a simple application, it often looks something like this, right? We have a front end, we have a back end, we have a database. It doesn't really matter what it is. For my specialty, it would be something like this, like a React Native front end, maybe a Kotlin middleware, Postgres backend, but it really doesn't matter. It could be PHP and MongoDB or whatever. There is front end, back end, and data. So we make this application. We try to do everything right. We do Agile, we do Scrum, we do things that delight users and minimal lovable products. Everything. We put it live and it works and the users are happy. And then someone in a suit shows up and asks, like, how are we doing? How many users do we have? How many t-shirts did we sell? Whatever the app was supposed to do. And often happens that we kind of forgot about those kind of questions because it's not user-facing, right? The user doesn't care. But this is a legit question, and it happens quite a lot that this kind of functionality gets squeezed. So you have to, in a very short notice, you have to find some kind of answer to that question. So what could you do? One obvious way to resolve this is just to log into the production database and figure out whatever needs figuring out. We won't admit to ever doing that, of course, but it does happen. So that's the super hacky solution, but there are a little bit better ones. We can use some kind of analytics dashboard that just connects to the database, so in a very generic way. It's kind of the way our forefathers would build analytics. And again, it gets the job done, but it's not particularly pretty, right? It's not like it feels like a structurally sound solution, but it does get the job done. So if we're going to compare the pros and cons of this approach, well, it is simple. A nice plus is also that it separates analytics from the product team. The product team doesn't really, who built app, doesn't really need to concern them that much with analytics. There are some cons. It's hard to make sure that the analysts can only access certain data, that there are no leaks there, so it's hard to lock it down. Another big one is that if you run some massive analytics query, at the same database all your users are using, it will impact performance, and that's not something you typically want. Final one, also an insidious one, because we separated the analytics from the team developing the software. When they do change it, for example, they change the data model, your whole analytics might fall apart and they might not even realize it. So that's a problem. We can improve on that a little bit. So one thing we can do is make a replicated database. We have a database, we real-time sync it to another database. That's a read-only database. That solves one thing, and that's that when we query that database with a heavy query, it won't affect the production database. So we crossed off the production impact from analytics at least. But the other problems still remain. Now, if we want to have a more sound solution, because this is the age of APIs, API first, we can also define an analytics API, right? We can have we can design like a spec first API, we can document it, and we make everything nice. But imagine we are doing that. The suit had a question. We work really hard because it's a lot of work to make a proper API. For example, like the question is how many users per day use our service, something like that. We design the API, it works fine, it's beautiful. And the next day, the suit comes back and says, yeah, oh, that's really interesting. Yeah, I checked the dashboard and it had so many users per day. But was that more in the morning or in the afternoon? What were the age ranges of the user? Were they men or women? Like, the problem with analytics is that any answer leads to a new question. And if you need to update your API every time, it's going to be a long day, right? So what tends to happen with analytics APIs is either they get really, really complicated and a lot of endpoints with a lot of different parameters, or they get super generic. And this is of course a little bit hyperbolic, but something like that you have an endpoint that just downloads everything. A lot of the analytics APIs it gets down to that. It doesn't really put it like that, but that's basically what happens. So, conclusion, analytics APIs are hard. And combined with the fact that we tend to forget about them a little bit until later in the project, that's tricky. Now, this was about the simplest architecture of application you can imagine to begin with, right? So, and that's usually not how things work nowadays, because nowadays we have microservices. So we have that thing we had before with all its complications, and now we have many of those. So it just got harder. And it is even like a little bit worse than that. Because even if we just would multiply the number of services and all have analytics, possible, but we end up with having a very fragmented analytics dashboard. Because basically that means that you have to ask every individual services for analytics. And if it's a business question, it will probably not follow the same context of your service. So, for example, if you have a situation that you have some services, this is just a random example. You have users, you have orders, you have shipping, you have payment, something like that. And if there's a business question like if a late shipping influences payment date or something like that, it touches all of them, right? You need data from all of them. If you have 4 dashboards, none of them are useful. You have to have all of them. So it is, microservices make the thing a whole lot harder. So how do microservices typically do analytics? Well, usually they do something like a data warehouse. That's like the old school way, ETL. There are a lot of vendors out there who sell expensive products. And what ETL means is extract, transform, load. You extract all the data from different services. You design a pipeline. It's like an API, but like a streaming sort of API. And you load it into some secondary store. That's like the traditional way. Nowadays, we more tend to talk about data lakes, ELT. And that's like we switch the load and the transform. So we extract the data and we straight dump it into a data lake. And the philosophy of data lakes is first just get as much data as you can, throw it here, and we'll talk about later what or why or how. but it's just a big blob of largely unstructured data. The last one is event-based solution, streaming ETL, and that's what I want to talk mostly about because that's my thing. But all three are worthy of several talks by themselves, so I'll be focusing on the last one. And what would that look like in this case? So we are back to our original application that has its front end, its application, back end, and the storage. And what we're going to add is an event bus. Usually something like Kafka, Pulsar, there are many. But the idea is that we have something where we can write an event. We don't really need to know why we're writing the event, what will be listening to it, but it's just stating stuff that happens. And that's like the core of event-driven systems, that you just write events. So, for example, when you add a user, write an event. Delete a user, write an event. Everything is writing event. It's all append-only store. So then we can make an analytics system, and I really gloss over it because that, again, there's a whole lot of things to explore. But based on those events, you can reconstruct what happened. If you have the complete history of all events, you can even figure out the state at any moment, right? And that's very valuable for analytics. So there are a lot of ways to do that. There are a lot of commercial offerings for that. There are also like open source, like Apache Flink is really nice to do that kind of stuff. But if you, conceptually, if you have those events of all the things that happened, you can reassemble every data in any form you like, basically. And then store it, and then you have a dashboard. So if we go to the microservices setting, it looks something like this. We have our services, and they all put stuff into an event bus. And there are some nice pros to that, in the sense that we have low latency, because every event gets produced and then straight away can be absorbed by all the downstream effects. And also, every service can post whatever they think they need. And finally, it is still a regular application. It is not an event sourcing application. I don't know if you know what it is. If you don't, really research it, because it's really nice and really cool. But I know for a fact that most developers will not like it, because it's very complicated. It really requires a certain way of thinking. So it's still a normal application. You read and you write data. The only thing you add is that you add events. There are some downsides as well. Schemas of events. That's something that's easy to lose track of. But if you send an event with a certain data format, maybe JSON or Avro or Protobuf, something like that, doesn't really matter. But the thing is, that event will remain for a long time. And if you change your code later to add a certain field to that event, the old events all still exist in history. So then you end up with a stream of events that have evolved over history. And that's something you need to keep in mind every time you change something, that if you have a database schema, it's a little bit easier, because you can change it and the database lives in now. So if you have changed it now, it's different. But with events that span history, you can't change the past. So another thing is that the service teams need to work with analytics. They need to do actual work to make this happen. And every time they add a feature, they need to think of, what events do we need? Do we need events? And again, if you really focus on the end users, probably it will be forgotten at some point again. The third one is a really insidious one, and it's called dual rights. And dual rights, I'll have a separate slide for that one, means that we both, for example, if we add a user, we insert in the database and we write the event that we created a user. What if one of the two fails for whatever reason? That is tricky. For example, if we insert it into the database first, but then somehow the event doesn't get written, we have a kind of user that exists, but from an analytics point of view, it's not there. And as it is persistent over history, that off by one error will remain, and it's really hard to fix. So that's a problem. Other way around, if we send it first to the event bus, then we update the database, and that fails, then there is kind of a ghost user that only lives in analytics but doesn't actually exist. So you can't really get that right that way because we don't have transactions. We don't have a thing that makes sure that either both works or neither. So for that, I'd like to introduce change data capture. I would like to ask if any of you have used it before, but I can't see. Yeah, I have one. It's hard to see. But change data capture is a really nice concept, I think. And it actually kind of feels new, but it really isn't. It has been around for a long time. And what change capture does is you connect to a database, doesn't really matter which one, and you get a message for every time something changes. And it also can do it for the data that's already in there. So you can kind of a sort of virtual history of all the data that's in there. And then you can just keep listening and you get all the changes that happen. That is a really powerful thing. How it works is basically because even though there are a lot of different databases, there are some common things. And pretty much all databases have some notion of a write-ahead log. That when you insert or change something in a database, you first create a message in a sort of log that I want to make that change. And if that is officially persisted by the database, then it will actually perform the change. And MySQL calls it the bin log, and Postgres calls it the write-ahead log, and there's an ops log in MongoDB, and there's archive log in Oracle. They all kind of seem to have invented their own way to do this very same thing. And that log is typically used also to make replication databases, like read replicas. Or in case of crashes, if your database crashes in the middle of something, you can figure out from the last snapshot the database made, you just follow the changes that should be made, and then you can get back into a consistent state. The tricky part of that in databases right now is that most of them are old and they're all a little bit different, so it's really hard to make that work consistently. So, yeah, as I said, they have all their own spin on it. If you don't know it, this is a really nice project, I think, the Bezium. It's from Redhat. That kind of standardizes that. You can connect to a database in a standard way, and it will more or less give a consistent way of reporting messages from different databases, even though internally they have all kinds of differences. So look something like this. It supports many databases, they're working on more even, I think, but it's ever growing. And it comes down to that you basically run the Bezium service and you point it to a database. Here you kind of explain where is the database, what configuration, Kafka Connect for the ones who in the know. And then it will start spitting out messages. And I don't know if you can read it, but this is like a payload of the message, has a before and an after and some metadata. And before and after is basically a row in a database that changed. In this case, it's a fictional movie, and what changed was the release year from 2007 to 2008. Like you have a really precise view on what's happening in the database. So, if we go back to our creating analytics from our application, look like this, right? We have the front-end application storage, and we send messages into the event bus. We can change this to use change data capture, and then it looks like this, right? We just store data in the database, and the database captures the changes and writes that into the event bus. So that changes things a little bit, because we have eliminated two of the cons we had before. Because as we have automated in a way the sending of events, it means that now the service team doesn't even need to be aware of it. If you write to the database something, it will generate an event. So we basically solved all of them, because also the dual writes, right? Because there is no dual write. You write into the database will only publish the message if the transaction worked. If it doesn't, it will not publish anything. So there is a consistency there, and it's a whole lot easier now. On the flip side, we now created kind of a coupling to the internal data model, which might be a no-no or maybe not. It depends a little bit. But that means that if the application changes its data model, it will change the events from that point on. And that's something to be really aware of, because, for example, if you remove a column, it might be completely fine for the application, but the analytics might really miss that column at some point, and then you have to deal with that. There is a variation on changing data capture, and that's called Outbox pattern, and that works like this. You have special tables in your database you kind of only use to send events. So so the sole purpose of that table is to send events. And what you do then is basically that whenever you want to insert something, write an event to the event bus, you do the change and insert into the event table in a single transaction. So then we still have our safety for dual writes, because it's transactional by the database, and either it gets written or it doesn't. It is not free. We have been freed now from the coupling to the internal data model, because we can insert whatever we want into that table. But on the other hand, now as a service team, you need to think about that and add whenever you want to insert something, you need to deal with that extra table. So that's kind of a trade-off. So now we end up with having about 3 different approaches. The easiest one, the first one, manual, just send events. And maybe in many cases that's completely fine. If you're okay with, if things go wrong, that you occasionally miss one message. If that's okay for your analytics, if it doesn't need to be precise, easiest one. Change data capture, easiest from the product point of view. But when migrating data models, you might get into trouble. And the Outbox, it's more work, but more flexible towards the future. So that's something to decide on. So, but let's zoom out a little bit. So we have services, we have analytics, we have a whole bunch of topics going towards something that does analytics. And that's a pretty decent place to be, right? So, because we separated the two, we have just streams of messages and we have analytics, and we can kind of play with them separately. Which analytics tool we use, we can see, we can choose, we can change. It will not affect the upstream application. So that's a definite plus, and any modern application will now accept Kafka topics. So now the fun part starts, right? What do we do with that data? If we think like a data lake, we just say, yeah, we just take everything and we play with it later. We don't know why, but we just gather as much data as we can. But there are some moral and ethical things with that, and also legal, right? We need to think about what data is in there. So, for example, it would make sense to allow users to give consent for certain data to use for analytics. It might make sense to remove certain sensitive fields from the data anyway, because it's just really sensitive, especially if it's combined with not very interesting for analytics. Then by all means don't put them in the analytics topics to begin with, because why would you? So consent gate basically has a link to a user database that will know if a particular user is okay with using a certain piece of data. and or anonymized data. It is kind of tricky though that you need to combine, if you're combining a consent gate with anonymization, is that you have to do the consent gate first, right? If you, for example, before, if you strip out all user information, you can't really do consent anymore because you don't know who you're talking about. So it does create some interesting interplay. And there is some interesting things about consent with historical data. Like if you revoke consent, to what? To things that happened in the past that are already shared, and do you need to unshare them somehow? It is kind of murky, and also the legal part of it is murky. You never get a straight answer about that. So it is harder than it looks. It seems like a very straightforward thing. It is not. Anonymization. Usually the anonymization, the way it is used in industry, comes down to just stripping out obvious personally identifiable things, like names, like email addresses. It is kind of too easy to think about it nowadays, I think. It is like when they show a picture of a criminal on television and they blur out the eyes. But if you know the guy, you recognize them still, right? So there is still a lot of data that is still there, and that's still kind of, you're not completely anonymous. Another thing we can do is reduce accuracy of fields. And that's kind of more of a shady gray area of anonymization. Like we can remove an email address and the name, but if you have really precise data about an address, that basically a laser pointer to your door, not that anonymous, right? But maybe some address information is interesting if you want to draw a map or something. But then you don't need to know exactly where somebody lives. It's nice to know, maybe in medical things, how old is somebody, more or less. But you don't need to know the exact birthday. But if you want to know maybe like a decade, are you in your 20s or 30s or 80s, right? So you need to think about how much detail do you need in all your columns. There's an interesting law nowadays, the right to be forgotten, and it's officially called the right to erasure, and it is a really dense piece of legal words. I tried reading it and I kind of failed, but in the sense of event data, it's an interesting question, right? Like, if you want to be forgotten, what does that mean? Like if I, for us, we're in medical field, so if you visit the doctor and you want to be forgotten, do you want to make that visit unhappen somehow? But things happened, the doctor did stuff, bills were sent, so you can't really be forgotten. You can kind of blur out some historical things, but yeah, it is hard to unroll back just anything that happened. So you need to find a way that is good enough, but at the same time, for example, if you are later calling like how many patients did a doctor have at a certain day, it would be weird if one patient files a right to forgotten and then that count goes down by 1 because it's forgotten, it didn't happen. Doesn't make sense from the doctor's point of view. So it is kind of tricky to get that right. And in general, event-based data doesn't really want delete. There are some features in event logs where you can kind of request a delete, but if downstream systems honor that and say like this row that has been deleted, you should delete it because it wants to be deleted somehow, but you don't really know, of course. But we are in a pretty good spot. We have some nice a nice stack where we can make the analytics stack work. We didn't really go into the analytics stack itself, the analytics part itself, just the transport layer in a way. Kafka is the obvious one here. The Bezium I mentioned. Pulsar is kind of a sort of successor to Kafka, but in many cases it doesn't really matter. I want to shout out Red Panda, which is kind of a compatible, wire-compatible version of Kafka, but in C++. It's quite a bit faster for tail latency, and it's a bit easier to run, but still a little bit immature. And Apache Flink is really nice if you want to do stream processing. But finally, I want to talk a little bit about de-anonymizing data. Because we talk about anonymizing data, is that thing reversible? And that comes down to that if you have enough data about somebody, it kind of narrows down who that is. There are some really nice research papers about that. For example, this is American research that tried to associate medical records with voter records, and it only used zip code, birth date, and gender. And it was really effective. It was over 80% effective. So that kind of means that even though there was not a name in that overlap, that now you have a bigger data set in a way, right? That has both medical data and the voter records and the party affiliation and all that stuff. So that slowly turns into this game. I don't know if you remember that. It's like a de-anonymization for children. And basically, it's exactly this, right? The more you know about someone, the more precise you know who that is. And even if you don't officially know, you know. And that's like a big deal nowadays, right? Because what happens is if you have two data sets that are officially not related, but they have enough overlap so you can combine them, now you have a bigger one. If you have a third one, it's easier to combine with the bigger one. So it's kind of like a snowball, and you get a big ball of data that kind of gets worse and worse. And I don't really see a way out of that, right? It's really hard to break that. So for us, when developing analytics, I would say, don't put all the data in one data lake, let's call it. We can, if we have different analytics questions, we can make different data little lakes, puddles, something like that, that are more focused towards that question. And if we just make sure there's only the data in it that is needed, combined with hashing the key, so that you can't really, if you have two sets, you can't really combine them easily anymore, then we are creating less of an issue there. But on the other hand, what we should not forget is that data is really valuable. And for us in the medical field especially, like medical data is really sensitive in terms of privacy, but using medical data literally saves lives, right? If we throw away all the data in the name of privacy, then, yeah, people die who don't need to die. So we need to find that. We need to have that balance. We need to have that. We need to keep that in mind. So in the architecture picture, it kind of looks like this. You have a consent filter where you strip out obvious PII if you want, if you need, and then you create different sets for different questions. You kind of have to balance that. If you have a very, very specific data set that can only answer a very, very specific question, you end up that every variation on that question requires a new data set, and that's a lot of work again. So you kind of need to balance that you can, that it's kind of raw enough that you can still answer variations on the same question, but at the same time you don't want to put everything in it so you can ask anything, because that would kind of mess with our big ball of data. So as takeaways, I would say, if you're developing an application, properly prepare for analytics. Really ask beforehand what the kind of things are we need and how we want to get it out of the application. Just as a reminder, not just the first part that we need analytics, but how is really important, because then you kind of have the time to do it properly and not be in a rush to do that and get something hacky. Second, I think streaming analytics is really nice. It is quite doable. It is a lot more elegant than the batch-based approach, where you just take all the data and you do the transformation and you put it into some data warehouse, which has a lot higher latency that you do like every night. You do a new analytics dump, and next day you can see what happened yesterday. And this can be up to, with a streaming analyst, you can get it down to milliseconds to your actual response. So that is really nice. Another thing I really like about is that it's kind of a gateway into event-driven applications, because you can, once you have events of stuff is happening in the system, you can start using that as well in the application again. So you can add functions like also like a Lambda kind of function that listen to a certain topic, that if a user gets inserted here, do this stuff. And it really decouples it nicely. So, and I think it is a lot more approachable than if you go full event sourcing. If you approach from that angle, it is a lot of commitment you have to make anything work. And I think about 80% of the developers will not love you for it. All the data vendors will tell a lot of stories. And I think it's important to really step back a little bit and listen to what they are really saying and what you really need, because they have a lot of beautiful promises. But be skeptical. I am definitely not saying that you should never listen at all, but be skeptical. And finally, I think take responsibility for the privacy, and not just the legal part of it, because the legal part in Europe now gets attention. Like basically you get a mandate from management, don't get sued. But there is more to it than that. There is what is right, what do we really need, and really talk about that with analysts, with different people, because yeah, I think as developers we kind of have to shape the world we want to live in, right? And we can't look towards the lawgivers to shape that, because they're always going to be late. So right now it's up to us to make sure that we deal with data in a sensible way, and I think it's up to us. So that's all I have. Thank you for listening. Thank you online. And are there any questions?
First of all, thank you, Frank. Round of applause for Frank for the presentation, starting the day. So I'm seeing fine, and there are no questions so far, but there are online viewers who maybe have some time to see the stream. It's a little bit of a lag. So are there any questions here in the audience to Frank? Yeah, the light. Yeah, we have one. Let's hear it out.
Okay, hi. Thanks for the presentation. Very interesting. I wanted to ask, when we change the data model, almost everyone thinks about, oh, it will change our production database, we need to prepare it. But not many people properly think about analytics or data-aware stuff that we already had, right? And you said it. How would you suggest how to treat a problem that our model will change? We will add a new field, or imagine if we want to change from one data type to another data type. How can we handle this problem?
Okay, changing the data types?
Yeah, so generally the question is, if you change a data model, how to deal with that in terms of events as well. It is not easy. I mean, if there was an easy answer, I would have said it, or it wouldn't even be a thing we think about. Generally, it is nice to move forward in a sort of way that doesn't break things immediately. So instead of renaming a column, for example, first adding the new one, making sure everything works, deprecating the old one, send a memo that this thing is gonna disappear, and then do that. Probably people don't read mail, so it will probably break still. But at least having a process there and being deliberate in it, that changing a data model is painful, that you just realize it. And do you really need that? So especially introducing a breaking change in a data model is a kind of a no-no. If you can get away with not doing that, that would be great.
Great question. Thanks. Do we have any more questions to Frank? Yeah.
Yes.
How does CDC solve this issue? Does it seem like it just moved the problem to a later stage?
No, not really.
Can we repeat the question for the audience?
Yeah, I will repeat the question. So, as I said before, that if you have the dual write problem we talked about before, that you write to an event bus and to the database, if you use CDC, you don't have that problem, and you ask why. And what happens is that CDC really gets fed from the guts of the database, right? The database has its own write-ahead log, and that's its internal thing. That is source of truth. And if it's there, it will do both things. If it doesn't succeed in publishing that event, then the change capture will know that it failed, and that it's still at that point in its write-ahead log. So it can, if there is something wrong, it gets blocked, but it will not skip it. So if your event bus never recovers somehow, then yeah, we're still having a problem. But we know where we were.
Yeah, thank you. Any more questions? It's great to have those. If no, let's give one more round of applause for Frank.
Thank you.
Thank you very much. Thank you, Frank. Thank you for a great presentation.